Yes, thank you. Okay, this will be quite different from previous presentation, at least. Okay, I'll try to at least mention a couple of times FPGA as a term, not as something what is inside, but okay, we are going in that direction, or at least we are trying to go in that space, and eventually we will succeed with that. We'll see. Okay, first,
Mislim da desno.
this one?
Ali možda Miša moram da...
Okay.
Ajde.
Good.
Sad si ti.
Okay, just a couple of sentences about Envox. We are around now for maybe too long, from 1996. We are doing lots of stuff. We started from something completely different, computer telephone integration at that time, and something what is what we are trying to do all this time is to develop software in-house, so not like some system integrator or just to be some distributor of some third-party solutions. And yeah, in actually now 10 years ago we started to work with open hardware, and we just try to see what is possible to do in that area. And we had two successful crowdfunding campaigns on CrowdSupply, which is connected with that open hardware. The first one was yes, strange name is H24005, means like hybrid 2-channel 40 volts by 5 amps programmable power supply. We started with in that time with Arduino Due microcontroller board, and but in that time we actually put color touch screen, and it's probably, I think we are pioneer in that area to put a touch screen on something like hobbyist power supply. And what we put have from the beginning, it's remote control via Ethernet and USB, using more or less standard Skippy protocol for working with such type of devices or instruments. And yeah, the next one was BB3. It's our main topics for today, what we'll want to do with it. So it is also fully open source, C certified. Idea was to put some extra, to put some additional modularity to the concept of the previous one. And yeah, we put lots of crazy stuff inside hardware and especially software. It was actually a test bed for our Easy Studio software. So yeah, as you can see here, there's like MicroPython, applets, MQTT, NTP, Node-RED integration, and we end up with more than 400 Skippy commands for remotely control it. Every aspect of it works. And yeah, we started to adding new modules. So idea was to have I don't know, 20, 30, I don't know, infinite number of modules, depends. But yeah, we are fortunately abruptly stopped due to that Corona situation, and basically since 2021 we didn't do a lot on the hardware side of the project. But yeah, from that time we had two DC power modules, some switches, multiplexers, and that mixed input-output, that MIO, which is yeah, probably very interesting because, let's say, MIO with that AFE3, so like analog front-end type 3, you have a complete power analyzer isolated, so you can monitor power on the secondary and on the primary and secondary circuit of, let's say, some device under test, and you can measure efficiency in real time. You also have some harmonics, power factor stuff, measurements and things like that. Yeah, we started with that, and it was that Mio. It's more than a prototype than a real or end product. But anyway, it was nice to play with it. Let's jump to the ideas and for improvements of that BB3. So as I said before, we didn't do a lot since 2021, and now in the last couple of months we start to think about probably resuming production of BB3, and during that process we start to think maybe what is better to just to try to resume a production of something what was developed many years ago, or try to modernize that design and put some old idea or even put some new idea in a product what we would like to continue to produce and to offer. So this is some let's like overview of what we end up in. Especially, I would like to thank to Jasmine. I don't know, Jasmine. It will be from Chili Chips. He was a devil advocate. He really questioning all aspects of BB3 in software and hardware sides, and he actually pushed me to start to thinking, let's say, outside of this box and try to make another box. Okay, so starting with the box, the first idea is to try to narrow the box so that we have now down to 24 centimeters. That means that two of that boxes can be fit in a 90-inch standard rack. So if someone want to put in some instrument rack, it will be much easier to put two than to use a complete one space with just one. To do that, first what came into mind is to combine existing three core modules. It's a power supply, MCU and backplane into the single one, just to put everything to be more compact. Also, 4.3-inch touchscreen, it's good, but why not go with something a little bit better, especially with the resolution? Okay, today you can find some 4.3-inch with 800 by 480, but why not go to 5-inch, and why not go to capacitive instead of resistive? With capacitive, you can go with that scrolling, with zooming and stuff like that, what you cannot easily emulate or accomplish on the resistive touchscreen. Next one, let's say maybe it's silly, but why not? Again, currently we have 80 millimeters fan, but in the same height we can put 92, so means more airflow. And actually, for the same price, we can find the bigger fan for the price of the smaller one. Micro SD card in the past was, like say, was for some people was a little bit frustrating, because it was maybe not optimally put on the front panel. and it wasn't so easy to remove it because it was actually mounted upside down, so on the bottom of the PCB. And also many people don't need to remove it, so why not go with a cheap version of SD card? We need some let's say mass storage within a box, but today some of that cheap version of SD card, it's really affordable. It's like $2 or $3, so why not go with that? And you don't need to take care about that mechanical connector where you need to insert SD card and stuff like that. Another one, it's try to also to optimize main power rail. Now we have 5 and 12 volts, and the idea is to go with bigger 12 volts with 30 watts instead of just 10, and have optional connector for if you need really lots of power. There is possibility to put another 200 watts external, or actually a small min-well converter, what can be also put in the same enclosure. We had a couple of digital input-output on the front. We'd like to put it on the back, on the rear panel, and also put some isolation, just to make safe communication with BB3. And this one is probably very interesting. Over the time, we actually realized that 35 millimeters, what is the current width of the BB3 module, it's basically it's too much for many purposes. It makes sense for the DC power module, that the DCP, where you need to put a huge heatsink. But for some signal modules, just a half of that, so it means 17 point something millimeter. It's more than enough to put everything, and still have a possibility to put on front panel some decent input-output connector. So with that, we can house not 3 but up to 5, maybe probably even 6 if we just want to put that additional half on all three positions. This is improvements of what we have right now on the BB3, but we also have some ideas for new features. Okay, soft power switch instead of that hard means that it will be easier for MCU to manage power recycling. RS480 485 port, it's with Modbus communication, could be interesting for many industrial and laboratory usage. Also power and sense terminals for the power modules for DCP would be nice to have on the rear panel if you want to put it in a rack. And this one, it's very important. So instead of have a fixed MCU on the main board, idea is to remove that and put it in the slot. And Goran already spend lots of time in working on that. What I came to that in some of next slides. And some of the candidate for that slot will be CM4 or 5. That's something what Goran already did. Another one, it's a SODIMM, and something what I also find interesting is that SMARC specification. So SMARC, it's currently there is more than 100 MCU and CPU modules which came into the SMARC connector, On that connector you have basically everything from various type of video, GPIO, LVDS, PCI Express, lots of other stuff. So it's looks pretty interesting. If we want to go with some of that, let's say, more powerful MCU or CPU module, maybe we should also put M2 slot for it's for solid disk, not HDD. It's for solid disk drive. So if someone really need to use it for some very extensive data logging, where you need I don't know, a terabyte of storage, it will be nice to put it on that disk instead of, I don't know, streaming that over the internet to some external storage or whatever. And this one is also already addressed by Goran and some of his and our joint efforts, is to offer external display output, so like HDMI compatible, if you don't want or are not allowed to mention that name. To display GUI and data to simultaneously on the TFT, on that 5-inch TFT, and on external display, or even to have two separate pictures, one or let's say like menus on the TFT and some I don't know, data logging on that bigger screen. There is more. Why not put some USB, not switch, sorry, it's a hub. Yeah, okay. I put that presentation a couple of hours ago, so didn't check everything. But anyway, so adding a small USB hub means that you can put also mouse, keyboard, maybe some other stuff over USB. Also have a separate USB device port with isolation when BB3 we want to connect BB3 with the external PC. Currently we have Ethernet port for 10 and 100 Ethernet megabit, but why not go with gigabit also? Of course, for that you need a more powerful MCU or CPU, but again, with that modular design, we can easily will find something with gigabit Ethernet. And this is also very important, and also something of what we are trying for sometimes, but okay, we was stopped in that some times ago, is to put 5 high-speed connectors, PCI Express style, because it's very cheap, and yeah, we can use it for LVDS or for PCI Express or even gigabit Ethernet. Gigabit Ethernet, it's have some advantage because it's already isolated. So if you want to have to keep galvanic isolation in between modules, what we have right now, gigabit Ethernet will be like probably more affordable than try to go with LVDS with isolation, because LVDS isolators from analog, it's like $20 or even $30 per piece. So we'll see. Yeah, onboarding FPGA, that's something why we are on this place. We really want to put FPGA on that new mainboard to take care of that video output switching. Again, we did something with that in the past, and also to manage that high-speed communication, to maybe for the routing, and I don't know what will be happen, what will be possible on that side, but having some FPGA at least as something for experimenting. I think it will be interesting to have on that new mainboard. And finally, optional USB 3.0 on the rear panel for connection with expansion chassis. So if you want to have another, this is also some of our old dreams to have expansion chassis to housing like 8 or 10 modules, and like have a combination of one BB3 with the touch screen and with display, another one with just with the modules. So we'll see what will happen. Some of the prior art, first, Envox, and in that time Radiona. Okay, Radiona is still here, but Goran is now in also in Intergalactic. In that time we started. Some of you probably can recognize some stuff on that screen here and even there. So this is a first attempt to put some FPGA resources on the BB3. Like, okay, it was funding by proof of concept around 8 by what was World Bank and Hamad Bikro, the local agency. And we actually proved that stuff like that it's possible and it makes sense to go in that direction. After that, Goran continues with NLNet funding, and he actually made that BB3 CM4. So like CM4, that means that our MCU module is CM4 compatible, and as you can see on that top right, it's a CM4 module from Raspberry, but it's also, there is a couple, you also made H7 from STM, and what else? ECP, yes, ULX 4M, yes, yes. So let's say that we already spent some time in thinking and working on that direction. So and have some experience at least. Partnership. If we want to go in and continue with that next generation, let's say BB3, I see partnership again with Goran and Intergalactic, and of course with Chili Chips. It's a powerhouse for FPGA, as I can imagine them. And okay, we'll see how it will works. And this will be the action plan. So first we need to secure development funding. Some of them will be internal, and also we'll try to get some money from NLNet again. Why not? It's probably last chance, almost. We need to design that new mainboard. We need to design that new MCU model, but probably this is something what Goran already did, so that H7 module. Yeah, if we decide to go with with CM4, we need a new enclosure prototype, that smaller one for bigger screen, for housing up to 5 modules or maybe even 6. We need, of course, a new firmware development. EMC precompilers. This is also something what I think that we can do together with Goran, because he did some real stuff in that area. And idea it's again to, if we want to make some production possible, we need to, let's say, to secure funding for at least 100 units, or maybe even more. So we'll try once again with crowdfunding campaigns. Again, we have some experience, positive experience with crowd supply as a site. So we'll see. CA mark certification or self-declaration, we will see how it will go. Yeah, initial production for crowdfunding fulfillment, and trying to add this time first high-speed modules, because something what we really want to have as again as a showcase or for test case is to have one high-speed modules. One of them will be redesigned at MIO 168, what I mentioned before, but also Jellyfish OPP. So that's why I want to talk with Igor, who is here. We'll see. Maybe some other, we'll see. But definitely we need some high-speed modules, and I think that even both of MIO and Jellyfish can address similar but different customers' needs, and I think that I don't see any obstacle not to go in direction to release both of them as using that high-speed module, because with previously Jellyfish definitely cannot work with that SPI and that bus what we had, and also the host MCU is I think it's not powerful enough to handle Jellyfish properly. We also realized that even with our MIO, so as I said, it's more than a prototype than a real product. So all what is left, it's a couple of rendering. So this is how that new baseboard should looks like. So as you see, it's this rendering. It's with this is the biggest one. It's a SMARC, but within the same footprint, we can put easily a CM4 or SODIMM. Next to him is that M2 for the SDD, and that big one of 80 millimeters. Here you see that new high-speed connectors, and this is that half modules, which is inserted here, and here. Now this is just one. This is a 12 volt, the main power supply, and here it's auxiliary connector for additional 200 if we need it. This is a 5-inch instead of 4.3. So, and this is a bigger cooling fan. From front panel, it looks like this. Maybe it's a little bit better to see. And from rear, it's what we have here. So this is a power and sense for dual DCP for the rear. So this is for the rack mounting. This is a digital I/O and RS485. External monitor. This is a device, USB to USB for keyboard and for the mouse. Gigabit Ethernet and additional USB 3 for expansion to go with expansion board. That's all. Yeah. Thank you for attention. If you have any questions. we'll see. We are really try to make it probably during this coming months. We'll see.
Here's a question.
Yes.
You mentioned MIO something and jellyfish.
Yeah.
Something else.
Okay.
What's that?
What else? You can go with, I don't know, multi-channel logic analyzer.
I have no idea what MIO is.
Oh, sorry. Oh, okay.
I have no idea what jellyfish means.
Okay.
Jellyfish.
Yeah. But yeah, MIO, it's like it's abbreviation of mixed input output. 8 means 16 inputs, 8 and 8 outputs, or vice versa. No, 8 inputs and 16 outputs, and it includes. It comes with also it's a modular. It comes with a piggyback where you can put different. You can choose what type of analog front end you can put, and there was actually we have a prototype for 3 different analog front end, but we actually did the most of the part of that one. What has simultaneous analog digital converter, so it's a 4 channel for voltage current for the primary and voltage current on the secondary, and it's isolated, so that you can easily go on the primary. You can go with up to 480 volts DC and 10 amps, and on the secondary it's up to I think 48 volts, something like that. And yeah, you can you actually can it's like a power analyzer, so that you can calculate power factor. You have you can calculate the harmonics on the and stuff like that. You can create. You can also measure with Fourier transformations what is what's going on with the channel and with the signal. The problem is that let's say for the power analyzer, sampling rate it's good enough, but for some faster purposes or application, we need something more bigger, more stronger, whatever. So we actually end up with 32 kilosample per second simultaneously on the 4 channel. What is it for let's say for calculating power factor? It's more than enough, but yeah, for something else it's not so. It's very modest. And jellyfish, it's Igor, as already mentioned, it will be a little bit later. It's a power profiler, no? Yeah. So
power profiler, battery simulator.
Simulator, and that. So it's very important when you're working with any type of project where you have a battery, especially for that Internet of Things, when you need to try to find out what will happen with your battery in I don't know 5 years times, or even a year time, or stuff like that. And with that power profiler, you can emulate the charging of the battery. So it's actually it can emulate a battery, how batteries works, stuff like that.
You can do reproducible tests.
Yes,
of the
yes.
different states of
Yes,
battery,
yes.
and you can precisely measure the
Yeah.
from the slip current of under a microamp to a few amps.
It's a completely different range. It's completely different, and sampling rate is it's much bigger.
It's around 100 kilohertz.
Yeah.
It's about 100 kilohertz of bandwidth, but the sampling rate is like 2 megabits.
Yeah, 2 megabits versus our 32 kilo. It's completely different.
Cool. Some
Yeah.
other questions?
So sorry, idea is for me to go with much faster ADC and also DA converter. So we also have a 2 DA converter on it, but again it's not so fast. But yeah, probably good for some simple like function generator or stuff like that. But for something, some real stuff, you really need to go with mega samples in both in AD and DA converter.
And you didn't mention, like on the picture, we know, few of us knows,
What?
but that Miguel did Scopio
Yeah. Sorry,
and
yeah,
helped us
yeah.
to actually to
Yeah.
combine two pictures. So
Yes,
one is picture
yes.
from STM.
Yes, this too. It's thanks to Miguel.
Yeah. So we have a picture from the STM, and the
Yes.
FPGA is capturing that image, and it shows both image, the Scopio project. So it's a oscilloscope on the FPGA with the overlay of the STM32 picture, because it is quite easy to make like GUIs on the STM with the Denis Studio, and it would be easier to use that GUI than to use background like Scopio in the background. So that was our idea at that point. So Miguel helped us to get signal synths and something. Yeah, it was. And okay, Denis, so that's it for the for you. So
Yes,
thank you.
That's an interesting topic for maybe later, how to
Mhm.
capture with the
Sure. Yeah, definitely. Yeah, Miguel can tell us a little bit about this.